When I was in Nigeria in the 1970s, I gained such appreciation from several of the clients there that I was made an honorary chief, and this dress was given to me as part of the ceremony. Right, we are scientists who are examining evidence, and we now need to link measurements to algorithms, to computers, to adding machines, to numbers, to data acquisition, to the Alexander cell, to CPN surveys, to stray currents, to the Nord Stream pipeline failure, to the scientific methods, and to the value of the CPN course. If energy is change, then measurement is the act of bringing order to that change. The earliest human tools for counting notched bones, beads, and marks on clay were primitive attempts to measure cycles of time and motion. Today, our computers carry this legacy forward using algorithms converting energy into binary codes that can simulate galaxies, predictive weather, or detect the faint signal of corrosion along a buried pipeline. Every measurement is both a snapshot of the present and a bridge to the future. The Alexander cell was born from this recognition that corrosion could not be managed by abstract potentials alone, but only by direct measurements of current at the corrosion cell. This step is as revolutionary in engineering as redshift was in cosmology. It turned theory into measurable fact, transforming corrosion science from guesswork into precision. The DCVG survey added another layer, allowing engineers to map faults over entire networks with clarity once thought impossible. What emerges is a unifying view of science. Whether we are studying the origin of the universe or the failure of a pipe, the goal is the same: to trace the path of energy, to measure its flow, and to anticipate its consequences. The expansion of galaxies, the discharge of a capacitor, the rusting of iron are all governed by the same relentless pursuit of equilibrium. In this sense, energy storage, batteries, corrosion, and even quantum theory are not separate fields, but chapters of one story, the story of transformation. Our task is not only to observe, but to master the tools that allow us to guide it. With the Alexander cell, CPN blockchain, CPN blockchain, and now computational methods, we are writing the next chapter with invisible currents become measurable, controllable, and ultimately the foundation for a sustainable future. Computers are just electronic adding machines that can only count to one. An algorithm is a structure simplifying related events sequentially. This enables a computer to calculate the trends towards probable consequences. Accurate data processed by this adding machine turns uncertainty into certainty. The Alexander cell and CPN procedures are the missing bridge between theory and practical reality. This makes our courses not just academic, but transformational. The practical impact on investigations such as the Nord Stream pipeline failure change guesswork into evidence. Information that is presently in the public domain about the Nord Stream pipeline. It consists of 4 physical pipelines. Nord Stream comprises 2 projects, Nord Stream 1, NS1, and Nord Stream 2, NS2. Each project consists of 2 parallel pipeline strings, often called Pipe A and Pipe B, so in total 4 pipes are under the sea. In 2022, explosions were detected and 3 of the 4 pipelines were damaged or ruptured. This information comes from the public domain published about the Nord Stream pipelines. It's not my words. Who owns and funded them? Nord Stream is operated by a consortium of companies, among them Gazprom, the Russian state-controlled, Wintershall DEA, EON, Gasunie, and ENGIE. These are the companies that own and operate Nord Stream pipelines. Nord Stream 2 was completed around 2021, but never went into service. Its certification was suspended by Germany, which was political, prior to the 2022 invasion of Ukraine. Before the sabotage, or supposed sabotage, though the pipelines were not actively used in full. They were pressurized with gas, but not actually used. So the gas wasn't flowing as much as it could have been. So as far as the public and technical record goes, there is no strong reason to accept the claim that 2 of them were never built. The engineering documentation, regulatory filings, environmental impact assessments, and shipping route plans all treat Nord Stream 1A, Nord Stream 1B, Nord Stream 2A, Nord Stream 2B as real pipes. I have not found these records or any documentation. Where there is ambiguity or room for scepticism. After the sabotage, the status of some pipes is uncertain, which are repairable, which are destroyed, and which might be left abandoned or sealed. Some investigations have been closed or limited by jurisdictional issues, making it harder to trace every last detail. For example, Sweden has closed its probe, citing lack of jurisdiction. Others have done the same. Because of security, sensitivity, full transparency on all contracts, security arrangements and black budgets, it is unlikely. There could be parts of financing, covert arrangements or state-level agreements that are not fully public. The sabotage itself adds a big layer of mystery. Who did it? How and why? Multiple parties have been suspected, but no final adjudicated conclusion has been universally accepted yet. Oil and natural gas themselves are lighter than seawater and would rise if laid freely on the seabed. But the pipelines themselves do not float because they are engineered, and here is why. The pipe structure, Nord Stream pipelines, are huge steel tubes, but about 1.2 meters in diameter and 40 to 50 millimeters thick walls. Each pipe section weighs several tons. 2. Concrete weight coating. To keep them on the seabed, every pipe joint is coated with concrete about 60 to 120 millimeters thick. This adds so much weight that each 12-meter pipe section can weigh 24 tons. The concrete coating also protects against anchors, fishing gear and seabed impact. 3. Natural buoyancy and overpressure. If they weren't weighted, the combination of the steel and gas inside would still have tendency to float because of the displaced seawater, Archimedes and all that. The concrete ensures the pipeline is negatively buoyant, in other words, heavier than the seawater it displaces. Engineers calculate submerged weight per meter carefully so that the pipe stays on the seabed even when empty or partially filled. Burial and stabilisation. Pipelines are trenched or buried under the seabed for extra stability and protection. Nord Stream is not 4 separate routes. It is 2 routes across the Baltic Sea. Nord Stream 1, built between 2011 and 2012 with 2 parallel strings, 2 physical pipes are laid side by side. Nord Stream 2, built 2018 to 2021, also 2 parallel strings. This is why people say 4 pipelines. They are referring to 4 strings, not 4 distinct corridors. Each string is full diameter pipe and each can independently carry gas. So, in practice, Nord Stream 1 is 2 1.224 kilometre pipelines. Nord Stream 2 is 2 1.230 kilometre pipelines. Total 4 physical pipelines on the seabed. Why build in pairs? Because of redundancy, capacity and flow measurements. 2 pipes in parallel double the throughput, allow maintenance on one string while the other string is in service. Manage pressure more safely over the 1.200 kilometres. This is standard in long subsea trunk lines. Cost justification. Nord Stream 1 was maxed out at 55 billion cubic metres per year capacity with its 2 strings. Nord Stream 2's additional 2 strings were designed to double this to 110 billion cubic metres per year. The controversy was not over whether it was physically possible, it was over geopolitical, economic and strategic logic, dependence on Russian gas, bypassing Ukraine, etc. So it was all politics. So the images in the public domain show one of these strings being welded and laid, but the total project always included 2 strings per system. There are no pictures of offshore pipelines being laid in pairs anywhere, ever, because this is impossibly complex and of no advantage. Each of the 4 pipelines were laid by an independent lay barge in parallel seabed corridors. The failure of the Nord Stream pipelines that are currently of international interest are studied using data obtained from physical modelling, computer analysis and understanding that has taken decades to accumulate. The most likely cause of these failures is accelerated corrosion that can consume steel at the rate of £17 per amp per year and could easily have caused the penetration of the steel wall in months. It is unlikely that the external explosions could be the cause because of the pressure inside the pipeline was proved to be greater than the pressure outside of the pipeline by the gas escaping after the failure of the metal. For proper investigation, the information required. In order to carry out an investigation into this matter, we need the following. All of the as-built drawings of the subject of this document, specification of corrosion control system, details of the pressure at which the pipeline is operational and the static pressure at the time of the explosion. Details of all metals used in the construction of the pipeline and the collar sacrificial anodes. Details of all electrical aspects such as grounding, isolation joints and flanges. All electrical energy data that has been acquired and reported, maintenance and survey reports. Geological reports of the whole area. Detailed maps showing the location of energy generating facilities and all high energy distribution systems. Reports of corrosion damage from all sources, including newspapers and media. Reports of any interference with any of these assets by anyone. All legal documents relating to these assets. Environmental reports, ownership, land and way leave documents. We do not have this information, so this paper is based on information and data in the public domain and results of experiments that were carried out as proof of concept. This scientific paper is for presentation at specialized conferences and for the attention of financial controllers, CEOs and government officials. There are many pictures available in Wikipedia and Google, as well as from mainstream and social media. None of these are acceptable as investigation evidence, as they do not stand scrutiny. There are videos, but these are directed at defined conclusions by the presenters of these videos. The Sonic Protection Network has case studies of pipeline explosions and the results of pipeline explosions in real life. We do not have the original report of these explosions, but have witnessed the results of other explosions firsthand. The definition of explosion is very important. A violent shattering or blowing apart of something as is caused by a bomb. What is the scientific definition of explosion? An explosion is defined as the rapid increase in volume and release of energy in an extreme manner. What is the legal definition of explosive? Except for the purposes of subsections D, E, F, G, H and I, and of J in section 845 of this title, explosives means any chemical compound, mixture or device, the primary or common purpose of which is to function by explosion. The term includes, but is not limited to, dynamite and other high explosives. This is lots of words meaning nothing. What is the difference between burst and explode? Balloons, bubbles, cushions, blisters and tummies can burst. Explode means there is an internal force or reaction, chemical pressure, nuclear, which destroys its container and perhaps damages the surrounding area. A bomb can explode, but not burst. Often you'll see these words used figuratively. This is very significant. What are the three types of explosions? There are three main types of explosions: chemical, mechanical and nuclear. Each type of explosion can be equally devastating and serious, causing unprecedented harm to the surrounding people, atmosphere and infrastructure. Therefore, understanding different types of explosions and how they occur is important. What happens when something explodes? There are blast effects. As the reaction progresses, the solid or liquid explosive material is converted to very hot, dense, high-pressure gas. The explosion produces products initially expand at very high velocities in an attempt to reach equilibrium with the surrounding air, causing a shock wave. This is very important. What are three characteristics of all explosions? All explosions, regardless of their source, are characterized by a large release of energy, the production of gas molecules that expand quickly, and a rapid rate of reaction. This is very significant. What is physical explosion? Physical explosions occur when there is a sudden release of mechanical energy, such as the discharge of a compressed gas. These types of physical explosions include vessel rupture and rapid phase transition explosions. In summary, a submarine pipeline bursts and causes a shock wave in the media to which it is released, which is at lower pressure. This picture shows the sea and the buried pipeline. Scroll up to the next picture. This picture shows the weight of the sea being a feature on the pressure inside the pipe when it explodes. So the explosion has to overcome not only the strength of the steel and weight coating and the buried sediment, but the weight of the sea above it. In other words, the explosion has to be very, very significant. The shock waves come from that explosion and are recorded on seismographic instruments. And these shock waves reduce in severity as they go to the surface. The result can actually be seen on the surface when the gas reaches the atmosphere and it then expands, causing the bubbles, and the heavier than air gas that is in the pipeline is released to the atmosphere, and it stays at a low level. It does not rise, but it is dangerous because any spark can ignite it. In the case of a pipeline failures, the pipeline metal is corroded to destruction and the inside pressure is released splitting the weakened area until physical